we know it's now recording. Yeah, so it's now recording. So welcome to today's session. We'll be covering chapters 7 to 9, right? 7, 8, 9. So let me admit this person. Yeah, so we'll be covering chapters 7 to seems like someone exited again. I don't know. It's not my fault. You guys are having a Wi-Fi issues that side. So we're going to talk about arrays, right? So let's go into arrays a bit. So I'm going to create a new tab, draw.io. So arrays in general, right? It's basically having multiple variables under one name. That's as simple as it gets. That's the whole purpose or the whole idea of an array. It's having multiple variables, or you can say multiple values under one name, basically to represent one thing. For example, you have a marks, an array of marks. They're all of the same type. That's another condition that needs to be met. They need to be all of the same type. If you remember, I hope it's with you guys. These days I'm mixing up my sessions. I'm confused whether I talked about loops with first years or second years. Yeah, I hope we did cover that, but I think we did. Remember, we said a variable, right, is basically a box, right? And then the name, whatever you've named the variable, that's the label on the box. And then the data type is the things that are allowed to be stored inside the box. So for example, if I have this variable int num is equals to 10, the label on the box is num. You could say number in full, so that you know that this box stores a number. Then the int will tell you what type of number it stores, which is integers. If you think about it mathematically, that means they belong to the set of Z, right? Capital Z, integers. Go revise your math symbols. So I'm gonna show you a diagram or the illustration of how an array looks, right? You can imagine, like I said, it's multiple boxes or multiple variables stored under one name. So if I have an array like this, and let's say this array is for my marks, right? For my practicals that I've been submitting every week. So I'm gonna put the name on the top there. This would be, let's say we're calling it marks. Okay, the name going there is not good. So let me put it a bit at the top. Then I'm gonna put in the position. So each of these variables, right, they're stored at a specific position. Just like when you go to Pick and Pay and you're in a queue, or you go to Capitec month end and that queue is long. Those people are in order, right? They're placed according to some order. In our world, right? In our world on earth, the way we count is count from one. We say this is the first person in the queue, that's number one, that's person number one. The second person, that's person number two. Or you can literally give them those you know those those lights that are shaped in the form of numbers. Imagine someone gave you a big light with a one, and then you'll be representing number one. Another person, the second person was given the light with number two, and so forth. So those numbers would actually represent your position in that collection of people, right? In this case, it's a collection of people in the queue. That number that you're holding will represent your number, your position. Another word for position in programming, we say it's an index. So this index would represent in what position are you in the queue. In this case, array start from 0. You'd have to go back to COMSI 1A to understand why they started 0. I'm not going to cover that because there's no pointers in Java. So to be honest, you don't have to know about it. But when you get to assembly, it just comes at 3B. Yeah, that's when you really, really need to understand what pointers are. And you really, really need to understand how an array works. I might, let me just, okay, I'll just send it, but then it's optional. You can watch or not watch. I did explain to first year's arrays using the addresses and everything. Basically, the reason we start from index 0 is because when you find the arithmetic, when you do what you call pointer arithmetic, right? You take let me think about the formula. You take the index, if I'm not mistaken, you take the position, then you multiply it by the number of bytes, right? Then you add that result to the current address or to the address of the first index. So that point arithmetic, right? It forces, in a way, it kind of forces us to go back to zero, to start at zero. Because if you start at zero, that means when I do my point arithmetic, if I say the index times the size, zero times any number is just zero. So it's going to point me back to the starting number. Then when I start multiplying by one, then it moves on to the next number. I multiply by two, moves on to the next number, and so forth. You'll understand that better in terms of pictures when I send you the link. I also do the same diagrams as I'm making right now. But then with them, it's first years, C++ has pointers. You need to understand it. I explained arrays to them in a different way. So we have these three boxes, right? Remember, each box represents a variable. So as you can see, each box or each variable is stored at a specific what? Position in the array. So that means when you go into the array, you're actually indexing, going to get a variable at that position. That's what it means. Or getting a box at that specific position. So these are my boxes, right? Or my values at every single index in my array, which is called marks, because this array stores my marks. Then each of these, there's another rule condition that needs to be met. The other condition is that they need to store the same thing. Basically, they need to be of the same type. It's like, for example, you have let's say, let me think of an example. Mm, what example can I make? It's hard to find an example that you can make. Okay, I can say, okay, let me, I thought about another example that you can think of. Imagine there's recycling bins, right? There's a bin that says only glass. There's a bin that says only cans. So obviously cans are of the same type. They're the same thing. So it's that bin has a collection or has an array of cans. And those cans, when you look at them, they're all of the same type, right? They're made of the same material, so the same thing. Then you look at the bin with the glasses on. You would expect to only find glass, right? There's no way you'd miraculously expect to find a child's diapers in there, right? Because why? Why would it be? Why, like, it will throw you off. It'll be like, okay, what's this now? Because this is a container that only stores glass. How come I'm seeing babies' diapers and stuff? So just like we have things like that, whereby each bin stores one specific thing, and that one specific thing is of the same type inside one bin. Arrays operate in the exact same manner. But then now arrays, they kind of specialized, right? Those things each box, you can somewhat think of it as like each glass that you throw in there, or let's say it's a glass of Coca-Cola, right? You're throwing glasses of Coca-Cola in there. So each glass of Coca-Cola, you could represent it at a specific position and line them up. I don't know how you'd line them up in the bin, but yeah, just imagine you line them up. They're lined up in the bin. So you basically have multiple things that are of the same type. That's why when you create an array, you're gonna have an array of only integers, an array of only strings, an array of only chars. So they need to always be the same type. So that's another condition that needs to be met. So since they're of the same type, right? That means here, remember your marks that are stored on Eve, what data type is used to store them? It's integer. So therefore, I would assume that each box is gonna store, it's gonna be of type int, right? That's because that's logically that's how it should be. I don't expect anything else. So let me just color it a bit to give it life. So this will be all integers. And I know you might notice something different here. These are still variables, right? But they have no labels. Why do we know why would you need a label when you find its position? So you see, it's easy, the computer can still find it. The reason why we would need labels, right? It was for our case, or in our sake, so that we can locate the boxes easily. We know, oh, this box stores an average, or this variable stores an average. So that when I want to output an average, I don't mistakenly output a total because I've given them labels. I've given them the boxes labels. So with arrays, there's no need for that because there's no way you're going to make a mistake because there's indexes, there's position. So yeah, this is basically how an array would look like in memory. That's how I would want you to picture it. So now, and another thing, in Java, arrays are not the same as arrays in C++. In Java, arrays, they are what we call reference types, meaning you can call a function on it, right? Or basically you can use the max name and say dot to access a function that does something to the whole array. Maybe sort the arrays, but that's not how you'd sort it, but that's just an example. Maybe you want to sort everything in ascending order or descending order. It's up to you. So how do you declare an array? So I'm gonna put in some comments from time to time. So let's start with 1D, right? So one dimensional, 1D array. So one dimensional you can, what would be one dimensional? Two dimensional is actually a straight line because we have length and width, right? Then three dimension would be length, width, and height. Yeah. So you have to think of it in terms of a physics perspective. Think about it in that way. If you didn't do physics, go watch a video about dimensions. You can picture it in that way. Still, if I would actually prefer you picture it in that way so that you really, really understand. So that you have that deeper level of understanding. For example, for those who doing Maths 2 calculus, you're going to talk about vector spaces because I remember seeing it somewhere with someone that I knew. Inside that textbook, I saw vector spaces. So basically, they're talking about 3D, right? 3D, how to represent that. Then they say in the I remember very well in the textbook, they said, imagine that part, whatever. I think it's the vector space. I forgot what that. I think it's the vector space. They say imagine that's someone's share. That's your shadow. Something like that. I was like, I like the way they're explaining it, but only if you guys can actually sit down and understand the English. English is very important in life. Even in coding, it's English. English. Go study English. So to declare one DRA, right, you're gonna put in the data type. There's two ways to declare one DRA. You put a data type followed by square brackets like this immediately after the data type. Then a space. I want you to pay attention to the way I'm doing things. Don't forget the spaces. Students' code is always ugly, man. Yo. Yeah, it's like you guys don't love yourselves. The way your code is just be ugly. You find the student's code is like this, right? And then chigi, you have a Kelly brace that side. You're like, what's going on in this person's code? It's all over the place. Do you know that in order to get hired, you just writing neat code might actually may give you more points compared to another candidate. That's how important neat code is in the industry. It's very important. They would actually make you not sleep the whole night fixing the code so that it looks pretty. Because for it to look pretty, there's a standard, there's a rule that's being followed. It's like, for example, tax. When you get salary, you need to pay tax. That's a rule. So coding is this whole thing of making code look neat. It's actually a very strict rule. You need to abide by it. You don't, oopsies, no job for you because they can't hire someone who's untied. Because someone's code can actually tell you a lot about what's going on, especially in their head. Maybe their room might be clean, but in their head, you can see if there's disorder by simply seeing the disorder in the code. So you're gonna have data type and then square brackets. This square brackets just tells Java that listen, it's a collection of values, right? And then you're gonna provide a name of variable. And remember, don't forget camel case. We're going to use camel case for naming the variable. This is the first way for creating the variable. Then this is the Java way, right? This one. This is what we call the Java way. Basically, the preferred way. I'm gonna put another comment here, preferred way, right? This is the way that they prefer you to declare arrays. Then for people transitioning, right? When you've transitioned from C++ to Java, they still use the C++ syntax only to accommodate those, but it's not advised. Remember in C++, you put the square brackets after the variable name. This is the C++ way, right? C++ way, not preferred. Remember, by prefer, it's preference. I know you might be like, yeah, that means it's not strict. That means I can write it in my own way. Yeah, you're gonna lose the job. Just know. The industry is no time for smiling. This is all sugarcoating stuff, making you guys treating you like babies. When you get to the industry, someone might even say the F word right straight into your face. Now you're dealing with real stuff. They tell you do this, do it. Make the code clean, clean. Don't be doing your own spiritual things there. Or else you're fired. Go look for employment elsewhere. So if I want to create an array of integers, right, I'm going to do it the Java way. So I'm going to put the square brackets after the data type. So int square brackets, then what's the name of the variable? Marks, right? Simple, right? There's my marks array. Then there is, that's the one thing I hate about Java. There's a lot of ways to initialize this. The first way, right, is to use what we call an array initializer. You're only allowed to use the array initializer upon declaration, meaning during the time you're declaring the variable, the array, that's the only time you're allowed. So you declare, put it like this. Then you initialize, you give it initial values. But you might ask yourself something, right? Arrays are fixed, meaning they have a fixed size. How come I don't see where I'm specifying the size? Well, like I said, there's different ways to declare them. This would be the way whereby you're just declaring it, and then Java automatically resizes this array to be the however number of numbers you've passed here. So if you passed two like this array is gonna be of size two. So this is one way to initialize it, and just make sure each value that you're putting here is of type int. So when you see this, right, when you see that 9 and that 2 like this, it's literally doing this in the compute. It's like, oh, so you want the 9 to go into the box at index 0. So it's going to take the 9 and then it puts it in this first box, index 0. Then every other value will be placed in the consecutive positions. So that's basically how the array initializer list works. So basically when you see this, so let me put a comment there. This will be starting at position 0, position 1, and so forth. However number of integers you pass is going to give you that size, then that means you must not exceed that size. Or in this case, in Java, we call it a length. In C++, it's kind of weird on which word to use. You can use length or size. In Java, it's called the length. So this is how you'd initialize that. So I'm going to leave that as a comment, just as an example, right? So just demonstration. Then there's another way, which is the most likely way you're going to do it, right? So it's like int marks. Then you say, remember we talked about it. I said this is a what? A reference type. Remember reference type, it means that it's based on a class, meaning that I can call a constructor. So I know it's weird in Java because you're used to calling constructors in a different way, but just bear with me. So you're gonna say new int like this, right? Meaning you want a new integer, right? You're instantiating it, that array. But you need to provide the size after the data type. Because remember, we talked about the Java way. You put the square brackets after the data type, of which that's the exact same thing you're doing this side. Then you specify how many elements you want in there where there's question marks. Basically, how many boxes or how many numbers should this array store. So since you have 10 practicals, I'm going to say 10. So it's going to store 10 numbers, which is going to represent your practical marks. Then you can have a lot of functions. Let me show you. You can say max dot. You see, you can, like I said, this is an object. You can say dot. You call the clone to make a clone, a copy. You can call equals to check if two arrays are equal to the another array, equal. Then you have the length. You see, the one that you're gonna use the most, it's this one, the length. Um, it's a length. It's an ax. It's a what? I think it's a static. I think it's static. Yeah, it's a static variable. I think this one. I think it has to be a static variable. So it's actually a variable. So you say dot length like this. This returns how many numbers are in the array. Basically, how many values are in the array. So I can test it out and say max dot length to just print how many numbers are in the array. Remember, arrays are objects. I expect 10, which is that exact number. So now you understand length. That's the length. You're gonna use length a lot. So no more of this C++ thingy of abo, if you still remember size of blah blah blah. If you don't know size of, you don't know C++. Well, don't lie to yourself. This is the moment of time where you're supposed to have some epiphany right now, and like some awakening, like, oh, I actually didn't know C++. I just crammed. Size of, you actually use it to find the length of an array. If you didn't know, well, I don't know. I don't know which ComSci 1A and 1B you did. So we have marks here. So how do you fill the array? Simple. You say marks, right? Remember, we looking at the diagram. The name of the array is marks. Then I choose which box to fill in using the positions or the indexes. Or in proper English, they say the indexes. Yeah, that's proper English, but I'm going to say indexes because that's the word you understand. So after the array name, the name of the array, you specify square brackets because you want to choose a specific position in your array. So I want to go to position 0, and then I'm going to say is equals to 100. Let's say your first practical, you're going in hard. You got hundreds on the dot, which I doubt. But yeah, you have your max array, it's at index 0. Remember what I said, at each position, it counts as a variable. That's why we're using it as a variable. Because if you remember, you can say value is equals to 20, something like this, which is exactly this. But then this is a whole array. We need to specify which variable we want to set, basically at which position. Then you initialize it. Then to print it is the same thing. You're just gonna say sys out, okay, sys out marks, but you can't just, you could, right? Technically, I know you guys are new to Java, but you could, this would work. This now, this now prints it in a different type of way. This prints all the values in the array that are available in the array. If you want to print one specific variable, you'd have to index, basically specify the position. So this, yeah, not entirely. Yeah, as you can see, not entirely true. So this is, I know this number looks weird, but um, yeah, I know that number looks weird, but that number just simply means the starting address, right? You'll understand when I send you that video. You'll understand why the 0 is important because, to be honest, the name of the array stores the address of the first element, right? Then the language itself, it uses what we call pointer arithmetic, basically to count how many times or by how much space or by what how many bytes must it move to get the next number. If you remember in our first introduction, you might that's why you might feel like sometimes you might feel like we're talking about topics that are irrelevant. For example, when I was talking that first lecture we had for revision, intensive revision, some people might not even have watched it. Yeah, this is the point whereby it separates boys from men. If you didn't watch it, now you realize that you have to go back and watch it. So I'm just gonna say bytes. I won't say what they mean because it's gonna waste time. We did talk about that. So if you have starting from 0, 1, 2, let's just say you have only 4 numbers. Just say for an example. And then the numbers is 6, 7, 8, 9. What happens with languages, right? All programming languages, they might not expose it, C++ exposes it. You can actually do pointer arithmetic manually, meaning in C++, you can access all the numbers in an array without specific indexing, just doing pure point arithmetic. I demonstrated that with my students. I'll send you that video. So how does it do? How does C++ know? Remember, we talked about each data type having a size, meaning the number of bytes or the number of bits. An int has a size 4 bytes. So that means each thing is separate. This is simple maths. Simple maths. Each thing is separated by 4 bytes. So the first 4 bytes will represent the first number. The next 4 bytes, it means 4. The next 4 bytes plus the current bytes, which is 4, so that's 8. So 8 bytes. 4, the next 4 bytes, meaning I need to add 4 to the current bytes, which is 8. So 8 plus 4 is 12. And then 12 plus 4 means I need to get to move to the next bytes. For next available 4 bytes, I need to see, I need to take the current bytes, right? The current bytes that I have, add 4 to it, which is 12. 4 plus 12 is just 16. So that means if you're looking at this thing from a low level perspective, you guys are doing Java, so low level is not your thing, but it is important to understand. So this is how numbers will be. This is how in byte form. That's how Java and C++ knows where to start and where to end. It looks at the addresses. It's like, oh, I started reading 4 bytes in, right? Meaning starting at it's not really starting at 4, if I'm being quite frank with you, but I don't have time to demonstrate that. That's going to take a lot of time. We have to go back to main memory. Remember, we talked about main memory, RAM. We have to go back to that thing and try to really understand all those things. Maybe also talk about stack and heap, which is unnecessary, like unnecessary information. It's only necessary when you're doing C++. With Java, you don't. You just need to understand the basics. So 4 bytes, it knows, oh, when I reach 4, that means I'm done reading the first value. Starting from 8, going upwards, it's the second value. That's the space area for the second value. So you can imagine those numbers right there, like, you see down here, you see these corners here. That's how Java knows. It knows, oh, I need to start at this corner and move. And then when I reach this corner, that means I'm done with reading the first number, the first integer. Then I start from that corner again, and then I move to this next corner. Let me zoom in a bit. And then I move to this next corner over here. That means that's where the second value ends. Those corners, right, they have what we call addresses. So it does point arithmetic. You might ask yourself, how does it know the space? How to space them apart? It knows because the data type, the size, the number of bytes, which is 4 bytes. So it's gonna be 4, and then 8, and then 12, and then 16, and then 20, and then so forth. What I've just taught you right now, you're gonna need to actually write it in code in assembly. So I advise you watch that video that I'm gonna send and you understand it thoroughly. Because like I said, there's no way of running away from things. You'll meet them some way. When you least expect it, like I said, in assembly, you're gonna meet this thing again. It might look like it's boring, it's useless. Wait until you meet it and you fail all of your practicals. In assembly, that's the only module whereby it's 100% possible to fail every single practical, like literally get a 0. ChatGPT is not gonna help you there. That module is built different. You need to know your stuff. You realize, you learn the hard way that ChatGPT doesn't help. We've tried using it, didn't work. Then we had to actually master it, and then we realized, oh, it's not so bad if you know C++, if you know point arithmetic, if you know all those things. It's not so bad. So yeah, there's the arrays, right? Then we can initialize them using a list initializer. It works exactly the same way. So you can, instead of saying 10 here, you can put a list initializer and specify 10 numbers, 10 marks. 88, 99, you got 0, it didn't submit again, 100, then 45%. Yeah, so this is just 3, 6, right? That's 6 practicals. Let's say you submitted 6 out of the 10. Then it will still work. If I index, let's say, remember this is position 0, position 1, position 2, and so forth. I want 0, 1, 2, 3, 4. I want position 4, which is going to be 100. So I'm going to try to print whatever's in my max array at position 4. I'm going to try to print it out to the standard output. There it is, 100, as expected. Then you can also change the values by assigning it at a specific position a different number, and so forth. Straightforward. Let's say you wanted to print all the values in the array. How would you do that? We go back to our for loops. Let me see. Let me try check something here. Oh, it doesn't have. Oh, it's not a. Yeah, it doesn't implement the list interface or the set interface or the map interface. Yeah, don't worry about that. This is for people doing ComSci 3A. I'm just trying to remember that thing. So we're gonna do a for loop. I'm just checking something because if you check, let me show you what I'm talking about. It is there in the array list, but then the array list, right? I'm not gonna import it because I just want to demonstrate something. You can put in the name of the list, then you say dot for each to do a for each loop on that specific list. That's what I was checking if it's possible. Then I realized, oh no, it's not, because it doesn't realize a list interface or a set interface or a map interface. There's those three in Java. So I'm just gonna do the follow up the manual way. So starting from index 0, right? So int I is equals to 0 because arrays are 0 index. They start at position 0. While my index or my position is still less than. Why are we gonna say less than? Because let's look at this. Let's look at from this diagram's perspective. The diagram's perspective is that all the indexes, right? You see that all the indexes, let's say you have like how many boxes do you have? You see here. 1, 2, 3. So that means if you were to call the length, right, dot length variable, you'd get the answer 3, right? Because there's 3. But then, okay, in my case, there's 6 here. But then from the diagram's perspective, the answer would be 3. So that 3, right? That 3. So let me copy this. I'm kind of explaining why we always check if it's less than. So that 3, the reason why we say I is less than 3, because we start at position 0, right? We check, is 0 less than 3? Yes, it is. Then we do something. We go to the next index. Is 1 less than 3? Yes, it is. We go to the next one. 2 is less than 3. Then we do something. Then now it becomes 3 and 3. Is 3 less than 3? Nope. Then we exit because there is no longer any box at index 0. At index 3, I mean. So therefore, we stop. If you go into this pattern, right? If you remember high school, they taught you how to find patterns. Use your knowledge from high school to find patterns. You can even do 3 or 4 boxes or 7 boxes, but the final formula, right, will be that the last index will always be a number less than the size of the array. So if you check here, right, the number of boxes is 3. And then the last index will always be 1 less than that size or that length, which is true. 3 is less, 2 is less, the difference between 2 and 3 is 1. So therefore, that sort of like hypothesis, however you want to view it, that hypothesis does actually turn out to be true, right? You can test it out with the different number of arrays, right? Different number of array elements. Or another way for it is array elements. So let me show you an example here. So 0, 1, 2, 3, 4, 5. Look at the last index, it's 5. But how many numbers are there? 6. Difference between 5 and 6 is what? 1. So like I said, that statement holds true. The last index is always the length of the array minus 1. That's why if I try to print this, you see this a lot in coding examples. They always, when they ask you to print the first and last element, you simply call the length from max dot length like this, right? Remember, this returns a 6. There's no index 6. To get the last position, remember the formula is that you get the full length, then you subtract 1 from it. And then if you wanna be Mr. Einstein and be fancy, you can say minus minus. You can do that. But nah, that's not gonna work because this is read only. You didn't implement it, you found it there. So that would but then that would be a nice way to apply your critical thinking skills. So this will print the last element. This returns the size, basically how many of them are there. Then remember the formula is that to get the last index, to get the value at the last index, it's always the length of the array minus one. So this formula holds true. Even if I decrease the number of elements, it will never crash. You see, 45, because that's the last number, right? So let me delete this 45, and you see that it's going to print 100. It will never crash because that's the hypothesis, and the hypothesis it turned out to be true. Someone figured that out when they were coding back in the day. So you don't have to try and prove to your lecturer or whatever. It's a formula that exists. That's how you find the last index. So I'm gonna leave that and go back to our array. So for int I is equal to 0, I is less than marks dot length, I plus plus, and then yeah. So we need to increment because if you look at, like I said, go back to high school, think about patterns, sequences, all those things. This will be term 0, term 1. How do we move from 0 to 1? We added 1. So that's why we're always going to say I plus plus. Because to move to the next term, we add 1. So this is what this part does, the I plus plus. Then let's say in my code, right, in my for loop, I just want to print the number. So sys out, print marks at position I. If you don't put the position, remember what I talked about arrays, right? They are reference types, meaning they store a reference. Remember Java, reference types are called reference for a reason because they store references or addresses. So if you just only print marks, that's why you're seeing a weird hexadecimal number because it's actually the address of where that array sits in heap memory. Because remember, we use the keyword new. So it's stored in heap memory. Then we get back an address pointing to the first element in that array object. So yeah, I hope that makes a lot of sense. So these are the numbers, right? 88, 99, 00, 145. These are all the numbers. And they're printing on a new line because I use print line. You could just simply say print. But then if you leave it like this, your output is gonna be weird because they're gonna be squashed together. It's gonna be 88, 99, 00, 100, 45, which looks like it's one big number. That's why you need to understand your code. There's the output. So that's why I'm gonna say plus a space. You can put it a character as a string, doesn't matter, as long as that space is there. So that when it done reading that number, right, it's gonna put a space. Reads the next number, space. Next number, space, space, space. You see that we end up seeing this output. So yeah, that's how the programmers were coming up with these formulas. They had to sit down and think about what they are doing, not just cramming. You guys have a tendency of cramming. You learn the hard way. Hey, it's not nice final year. If you're cramming the whole way and you're doing informatics, may the grace of God be with you. That's all I'm gonna say. Cramming is not gonna help you in any way. You have to make sure you read that textbook. This is not there is nip up and place. Not time to play around here. You need to read that textbook if you are majoring in both comp sci and informatics, even just comp sci and another elective. You need to study. You'll learn the hard way when next year everything requires you to read the textbook. So this is how you print the array. There's also different functions, right? I can show you one, right? I can show you one. What if you wanted to copy from one array to another? Let me show you. Let's explain something about references, right? Do you actually remember pointers in C++? If you create a pointer and you use that pointer, which is that address, as a new address in another pointer, you're simply pointing to the same thing, right? If you remember that very well, you're still pointing to the same thing. So you need to understand the difference between making a copy and actually just pointing the same object. You don't want to point the same object. Most of the time, you want to make a copy of the object. So this is the problem when you don't understand what you're doing. So I'm going to say values, and then I'm going to say is equals to marks, right? Remember, I said marks variable, the marks on its own, when you don't index, it simply refers to the address. So here you're taking an address and putting it in there. That means if you were to do something spiritual like this and you say index 0, change that to 200, you've also changed marks array without intentionally knowing it. That's why I mentioned this thing that arrays their functions, right? There's a function called clone. You can call the clone to actually make a clone, not to point, not to copy. So that you get a copy, not the original. Or else you're gonna be changing one array and thinking you have a copy and you don't. So let me show you what I mean. So if I try to print out this, right? Remember, I changed values at index 0. That's what I've changed. But I'm gonna try and print marks at index 0. Then I'm gonna think, it's gonna be 88. I'm the goat. I know how to code. And then boom, it's 200. Now you're asking yourself, how did it change to 200? Where's the 200 coming from? You need to understand what you're doing. That's the problem with cramming. This you see this over here. This is the results of cramming. Those who have crammed, this is what they'll be writing in that venue when they're doing semester test 2. Cramming is not the way. So here I can there's two ways, right? You can either call the clone method. I doubt it doesn't actually work. I doubt. But I think the fact that is they should work. The thing is, some things you might think they work the way they intended to work, and then you realize they don't work that way. So that's why I'm kind of doubting a bit. But let's try it out. Let's try to make a clone, right? By calling the clone method. Just like think of it for the science geeks or whatever, for the sci-fi enthusiasts. Think of it as you're in a laboratory, right? In a lab, and they are making clones there, which means it's a copy of the original. Which means that they're two things that are mutually exclusive, right? They're independent, right? They're on their own bodies. So that's where they took the whole clone thing, right? If you don't understand clones, go watch this movie. They cloned Tyrone. It's a very nice sci-fi movie. Go check it out. You would understand the clone. Yeah, it's called They Cloned Tyrone. So yeah, so the clone function does actually work, which is good. I expected it to work, but at the same time I had a bit of doubt. I guess Java is not like C++. C++, you just you think you know with C++, ne? And then you click the run button, then you have your fingers crossed. Please work the way I intend you to work. That's C++. You can never know. Unpredictable behavior. In Java, it seems like most of the time it's gonna do the thing that you expect it to do. So you see, I've cloned. So that means I've only changed a copy here. I'm working with a whole different copy. But if you simply remove the call to that clone function, you're not working with the copy, you're working with the original. That means you're just simply pointing to the same array, to the same object, which is the same numbers over here. So that's why it's very important to understand what you are doing. Then we have two-dimensional arrays. Two-dimensional arrays, hmm, I don't have time for that. But I'm gonna show you two-dimensional arrays. I don't have time for it, right? The full diagram. I don't have time for it. It's gonna be quite a long diagram. Not really, but yeah, just laziness. But I don't have the luxury to be doing that. So 2D, like I said, think of it from a physics perspective, right? So 2D basically means you have a row and columns. That's all. That's a 2D array. You have a row, and in that row you have columns. So that means I can say row 0, column 0, I get a box, I get a value. Row 0, column 1, I get a value. Row 0, column 2, I get a value. So that's the distinction, the difference between them. There's 1D, one dimension, meaning you're only focusing it on one dimension. Then two-dimensional arrays, you're focusing on two dimensions. You can think of it as the row dimension and the column dimension. If you go to your calculus textbook, you should find better terminology for that, the mathematically correct terms for that. But I think we can also view it as terms of like width and length. Yeah, you can also view it in that way. Then when the 3D, that's when you factor in the height, if I'm not mistaken. Yeah, factor in the height. 3D, that's when you have things like the box, a cube, something like that. That's like 3D, three-dimensional. So yeah, you must go do your own research on that. So let's talk about 2D arrays. They work the exact same way as 1D, 2D arrays. They work exactly the same way as 1D arrays. They just simply now you have basically have two positions to represent. Since it's in a two-dimensional space, so you're gonna need two numbers. Okay, for those who don't know, 2D is like a picture Cartesian plane. You have X, Y coordinates. In our case, it's not X and Y, it's a row and col. In our case, we can picture it in that way. But on a 2D array, picture it in terms of a Cartesian plane, right? That the Cartesian plane represents 2D objects that are mapped onto that Cartesian plane. And until you get to things like what's that topic? You know that topic when they say you reflect about the y-axis. Yeah, that one in Maths 1B. Yeah, that one. I think it's like I forgot the topic, but it's like discs and washers. Yeah. Uh, don't think about that one. That's too advanced. That's not that one. We're talking about just lines on a Cartesian plane or just a rectangle on a Cartesian plane. So that's 2D, right? With X and Y. When you're talking about the cones that are spinning, like, hey, nah, that's spiritual. Don't overthink. So I'm gonna create an array of things. An array of what? That's the thing. I don't know what I'm gonna talk about. Let's say it's an array that represents my game. The first dimension will be the X. The second dimension will be the Y. Then since I showed you this technique over here, right? I'm gonna show you a different technique, right? Using the constructor. So new int, specify the sizes here. So let's say there's 3 rows and 3 columns. You can imagine this is like a X's and O's, right? So X's and O's game. And O's game, right? So since the X's and O's, yeah, I need to actually change my data type. So let me use char because X is a character, is a char. O is a char. So I need to use chars. So there's my 2D array, right? I've given it a size. So this first size, this first 3 here, it sets this first dimension. Then the second 3 here, it sets the second dimension. That's how it works. So now when you're accessing, you're gonna need two indexes because it's a two-dimensional. You need to the first index mentions the first dimension. The second index mentions the second dimension. I'm actually kind of making you understand maths a bit better, like especially your Cartesian planes. I think most of you guys were just cramming and cruising through, didn't even care what it means. But yeah, the first dimension represents the x value, meaning you're looking at the x line, which is horizontal, right? You're looking at that horizontal line, which is your x's, right? Your x-axis. Then the second dimension would represent your y-axis, which is your vertical line. So that's what I mean that each number represents its own dimension. So I feel like now you can understand what two-dimension means, right? It's basically two lines that meet. You have one line that represents its own dimension. You have another line that represents its own dimension. Someone did talk about explaining dimensions on YouTube. I also send you that link on that. Even on the YouTube channel called Numberphile, I also send you links on that. So that you can understand the dimensions, because if you can't picture dimensions, you can have issues with JavaFX. That's my concern. That's my main concern. If you can't picture dimensions and understand the things, then you're gonna have issues with JavaFX. I've noticed people who are good in mathematics, like they understand dimensions and stuff. They know how to calculate. They don't have issues with actually designing the grid from scratch without having to refer to the slides and textbook because they just use their mathematical understanding to measure and say, oh, I can use a difference of 10. Then, okay, that'll be placed in that top right corner. You see, that's just simple maths. So let's set our game characters, right? So let me start at 0. 0 is equals to x, right? Then I'm gonna have to repeat this a lot of times. I could, right? We'll talk about random number generators, right? Talk about that. I could do that, right? I could do that, but not at the moment. We're not gonna do that. Right, so this would be all ones, this would be all twos, and then this would be 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. Then I'm just gonna choose randomly XOX, then just say oh there. Yeah, I'm just choosing randomly here. There's nothing special. There's no pattern to it. So this is my 2D array. So this means this value X will be stored at position 0, right? Like I want you to picture it in this sense, right? You have one representing the row, one value representing column. Basically, from a Cartesian plane perspective, this 0, this line, this row represents my x-axis. The columns represents my y-axis. So you think of it from that perspective. Then you can print your output your game and do all of that and change the characters exactly the same as a 1D. But the only difference is that now you specify 2 positions. And there's another beautiful part about Java's arrays. You can actually have like arrays that have different lengths. You get what I'm saying? At different positions, there's different lengths. So let me just print this out. So I'm gonna say for and I is equals to 0, I is less than. Now you need to kind of use common sense. You need to kind of understand these things. I'm gonna teach you something that you should use. This is actually they expect you to know this. It's not like something. So you're gonna say game dot length, right? And then I plus plus, right, as usual. Then we need to go through each index of that because it's 2D. So we need 2 for loops. So basically, just be careful of how you name your loops too. You start by naming them I, and then that inner loop J. If there's a third one, you're gonna call it K. The third one, that's when you're doing game development or 3D stuff, of which you're most likely not gonna do, unless if you're passionate about that. Just know that that requires linear algebra, getting 100% linear algebra if you wanna do game development. I hope you understand what that means. Getting 100% in linear and 100% in discrete and calculus also. So you need to know all three: linear, calculus, and discrete. Know them thoroughly, know the formulas, speak them. If I wake you up at 3 a.m., you speaking those formulas. I open the random page, you tell me what's the equation. That's game development. That's just the maths part. Then you go to the physics part. You need to understand deep physics, not just your university level physics, like third year type of physics. Then once you're done, yeah, you are done with those things. Let's say you push that. Then you need to know Java if you're using Java. In and out. It means reading that whole textbook. So some streams that you guys are thinking of measuring, they're not as easy as you think they are. So now when I want to get the length, right? If you notice something, I want you to notice a pattern here, right? You see that at index 0, I have 0, 1, 2. Right? So I have a whole array. At each index, I have a whole array. So this basically translates to at index 0, you have an array which has positions 0, 1, and 2, right? At each index, I have a whole array. So since at each index I have a whole array, I can get the length at each index. So I can say game at I and get the length of each array at each index. Then I'm gonna say J++. Yeah, this is something that's kind of new. for you guys. This syntax of it is kind of new, but you're gonna have to get used to it. Then you're gonna output the values, right? So I'm gonna use print. Okay, I could do that, but I was thinking of a different way, like using printf. Let's experiment. Let's use printf so that you guys become familiar with different ways of writing code. So printf, what do I want to print? I want to print the X or O value, right? So percentage %s, which is going to be a string, or in this case, it's a char. So I'm going to use percentage %c for correct. Then after that, I need to put in a, what is this? A space, or else it's going to be in one line. So I need to put that space there. Then, yeah, then I'm done here. Then after the first for loop, this is now going back. If you still remember game development in C++, ComSci 1B, 1A, I mean. This is basically similar. Now it's no longer C out ENDL here. It's now just system.println. Still similar. If you can use common sense and find the similarities, it's still the same thing, just different syntax. So if I run this, what did I miss? Oh, I'm not done writing my code. What am I doing? You see, when you get caught up with explanations, printf, you need to provide the variable you want to print, which is that game character position ij. Right, I forgot to pass that. Then we'll run it again. So there's my output. So this will be my game. If you guys actually subscribe to Hyperskill, there's a sort of like a practical whereby you must actually implement this game. And you can also play with the computer, or you play with yourself, or the computer plays with itself. It goes down in coding, yeah, and you have to write it in Java. So yeah, that's why sometimes it's important to practice. If you have enough practice, you get used to it. So this part over here, right? This might be a bit unfamiliar, but it shouldn't make you worry a lot. Remember this first I, right? It goes through all of my rows. So there's row 0, there's row 1, there's row 2. So at each row, that's what I'm saying here. At each row, I'm getting the length of that whole array. Why is this the syntax in Java, right? This. Why can't I just write 3 there? Well, you can't, because in Java, it is what we call arrays that have varying lengths, right? So I can create an a2D array, right? Let me show you an example here. So let's say it's gonna store values, right? I think, didn't I have a values array somewhere here? Yeah, I'm gonna go to numbers, and then I'm gonna use the array initializer, right? And like I said, you must do it in the same line. Don't try and do this. Then you say numbers, then it's equals to this. Then let's say 0, 1. This will crash. It's even stated in the textbook. This exact thing that I'm explaining right now, it's explained in the textbook. They even tell you don't do that. So you need to initialize it on the time of declaring the variable. So in Java, you're allowed to create arrays at each position. Remember, we have one number of rows and number of columns. And the number of columns will be the same for the number of rows, right? At each row. That was true in C++. In Java, it can vary. So let me show you an example. So I can press enter there so that it shows me a bit of space to write. So I can say this is 1, 2, 3, 4. So at index 0, this is position 0, right? Meaning row 0. That's the array. Then I need to put in a comma there to specify the next number. Because remember, this is a 2D array, right? Remember, this is a 2D array. So at each position or at each index, it's another array. So that's why it's like this. Unlike if you check there at the top, this was 1D. At each index, it's just the value because it's one dimensional. And this one, at each index, it's a whole dimension. Then in the second index, I'll just say it's 3 and 4. Java allows it. That's why this is very important over here. This is why this is very important because the length changes. So you need to get the index So index 1 here. So this means to go to index 1, get the length of index 1, of which case it's 2. You see, it's different. But if you had go to index 0, the length was 4 because there's 1, 2, 3, 4 numbers. So the length varies in that sense. So that's why we need to write our for loops like that if we have a two-dimensional array. It's a must. That's the only way you should write the loop. So if I write the loop here for the next, to output these numbers, in the exact same way I wrote the previous loop, you see that it will work without any crashing, right? So dot length, I plus plus. The first time you call dot length, right, this, you're actually referring to this one, this dimension, which is the rows dimension. So basically that gets the number of rows. Then you can go at each row and get the length of how many numbers I at each row. Because remember, we talked about these arrays. At each index, it's a whole array, it's another collection. And it can vary, you can have a different number of them. Remember to add the next number, you need to put a comma. Then I put in curly braces, then 10, 45, 44, 233. So you see that it's different lengths, right? So this is the index 2. At index 0, it's 4. At index 1 is 2 numbers. This is 4, 6. This is 6 numbers, right? Then I'm going to do that loop, which is going to accommodate all those lengths. No matter what the length is, it will accommodate all of them. Not game, what am I saying? It's numbers. Numbers dot length, then numbers at index I dot length, and then J plus plus. And then curly braces there, then system dot out. I'm gonna use printf again. Here I'm printing integers, right? You see, it's an array of integers. So I'm gonna use percentage %d, then a space, and then comma, the number that I want to print, numbers at index I, J, right? Then I need to print out an end of line character. I'm gonna use printf again, then pass in percentage %n. We talked about percentage %n, right? Percentage %n means backslash n, which is just like to print a new line character, right? So I'm going to use that. Then we print, and then these are our numbers. There they are. No crashing, nothing, no issues. That's why we don't put physical numbers in our second for loop, because if we do that, it's going to crash because it's not fixed. It changes at each index. I don't know why Java I don't know what was the reason for them to get to that conclusion. But yeah, they saw it as a good fit to make the number of elements at each position vary, meaning they're not constant, they're not the same, unlike in C++. In C++, they're always the same at each index. So that's why we always know the right number. We don't have to follow this technique. So that's arrays, right? Then let's talk about classes, right? Then that should be the end of our session. So let's talk about classes. Let me see. Did I miss something out on arrays? Uh, kind of, but it's not really. Let me show you a different way to initialize an array. I say x is equals to new int. If I'm not mistaken, this should be allowed like this, if I'm not mistaken, right? And then 3, 4. No, it doesn't. Oh, it's a C++ way, if I'm not mistaken. Oh, it does allow you, so it shouldn't specify. Yeah, it doesn't want you to specify the number. The thing is, I've been coding in a lot of languages. I kind of mix them up, these things. They're similar. I don't know why they do that. They create a new language which is exactly similar to the previous language. Then they say, no, this one is better because, yeah, wow, it compiles faster. So what? Like, can we have like one or two, like 5 languages at most? They're just languages for everything. People get bored and they just create languages. And then the messed up part is that the languages are all similar. You have int there. Maybe in Kotlin, instead of a small int like this, they say int with the capital I. Like, can you just stick to one thing? So now you end up getting confused. One moment you think it's like it's that language, then you realize no, it's not that language. This is Java. Me, it's this way. Yeah. So in Java, you can also initialize your array like this, but I don't see why you'd want to do this part of a year. That's not necessary because you can just simply specify the curly braces. Because at the end of the day, you're still not specifying a size here. So what's the significance of that new int? So that you remember that this is actually a reference type. I don't know. Maybe you like do it that way. That's up to you. But that's just the only way that I forgot to teach you that you can also initialize arrays like that. Then let's talk about classes, right? So with classes, right? Okay, this was ComSci 1A. So with classes, what you need to understand about classes, right? We are trying to model something, right? A class. We're trying to model something. So a class, since we're trying to model something, we need to have a plan for that model, right? For example, you can say that that plan is what we call the blueprint for the thing that we want to build. So we can call it a blueprint or a plan or a template. That's what a class mainly represents. It's like we are writing the things that the thing we want to build is going to have. For example, we design the car. We create a blueprint for the car. We say, okay, we're gonna create a blueprint for a customized Maserati. And it's gonna be an SUV Maserati. I don't know. Maybe you're rich, right? You're not rich, you're wealthy. There's a difference between rich and wealthy. Let's say you're really wealthy. You send them $20 million. You tell them, I want a customized SUV Maserati, even if it's not there yet. I want to have my own one of one. You send them the blueprint. You talk to your people, your architects, or people, I don't know what they're called, the people who design the cars. So those people who plan and design the cars, how they should look. Maybe you contact them, then they send the blueprint over to the Maserati company. Then Maserati now has a blueprint or a plan on how the thing should look, the colors, the functionalities, right? For example, it can go from 0 to 100 in 0.3 seconds, something like that. Like it, all those things, all those features. You want it to be really fast, or you want it to be very lightweight. Maybe the material that they must use on the body must be material that's gonna make the SUV lightweight so that it doesn't affect the aerodynamics of the car, so that it moves faster. Because the heavier the car is, that means it's not gonna accelerate at a faster pace, right? Or at a faster rate. So things like that. So that's the plan. So each plan has two types of things. It has what we would call the characteristics, or these are some you can view it as like the traits, how the thing is, right? Then we have what we call the functionalities, right? How the thing is going to function, or how is it going to operate, right? In other words, I don't like how they do. To be honest, I don't like that definition, but I don't know whether it was in the textbook or it was Hyperskill, but they explained the functionalities part is basically you list the things that you can tell that car or the thing you're building to do to itself, which is very weird, but yeah, that's how they explained it, which if you think about it, it makes sense. But then not necessarily like do it to itself, but yeah, it kind of makes sense. Try to think about that and digest that, but to me, it kind of makes sense. So these are functionalities or traits, or you can also view them as like just the verbs. This will just be nouns. For example, when you have theory questions, right? Everything that's a noun, it's a variable. Everything that's a verb, you make it a function. That's how you know the difference. These are the traits. So, for example, you can have a class that represents a person, right? Basically, imagine I'm God, I'm trying to create a person. So, to create a person, I will know that a person needs a name. That would be one of the traits, characteristics. A person needs an age. Gonna keep getting older and older, whatever. That's the system that I built. I'm a God, I'm the creator. Then they're gonna have a family, right? But then family would be another class on its own because it's quite too complex for you to just make it as a primitive type. It has to be a reference type. So you're gonna have to have another class that represents what we mean by family. Then you can talk about the things that the person can do, which is run. So you can have a function to run, speak. If you remember in high school, what are verbs? Verbs are doing words, right? Action. Running, it's an action. Speaking, it's an action. So these are this is what would form part as the functionalities for that object. In this case, these are just functions. Then you can also have name, age, family, which is just the characteristics or the traits. So that's pretty much what a class would represent. And then after you've created the plan, remember this is just the plan. You write down the formula and everything, that's the plan. Then the next thing that you'd want to or what you want to do right after the plan is to what? Build. And I'm gonna somewhat mix the definitions, but like play around with the definitions. So we need to create the object itself. So you need to create the object. Basically, build it. You have the plan, right? Put the plan into motion. So basically, you're manifesting the plan into reality. That's basically what we're doing right now. You create the object, so you build it. So how do you build it? Another way, I'm gonna use this word loosely, right? But then just know it somewhat means the same thing. You're going to build the object or construct the object, right? Which just another word means creating the object. So you're building or constructing the object. So to build the object, you need to provide. So basically, in other words, right, we've defined our own type. So we can use this as a type. So I can say a person object here and say OPJ1, just call it that. Then to create this person, I would have to, you see the word create or to construct this person, I'd have to call the constructor, the person who constructs the object, the person who builds the object. Just like, for example, okay, you guys are not that rich yet, but when you're building a house, but then I'm so sure you've seen your neighbor somewhere, or you're passing by, going out on a date or something, you saw they were building a house, right? They should have been people who are architects who have the plans, right? The blueprints, big blue papers there. Hence blueprints. Those big blue papers with the plans on how to build a house. Then you have the people actually constructing it, which is the builders or the constructors. That's the terminology for it. In OOP, they say constructors, not builders. They say constructors because it's a. If you think about it, like you see, you need to play around with English. We're at a construction site because we are constructing something with our constructors. So yeah, you need to play around with English in order to understand why developers came up with those words to describe those concepts. So I need to call a new constructor. So this constructor, funny enough, is going to have the same name as the thing you're building because you're building that thing. Because the constructor specializes in building that thing. And if you omit, right, I'm going to teach you all of my skills or the things that I've learned from reading. If you look at this on its own, right, neglect this whole part. Focus on here to the up until the semicolon. Does this look like a function? Well, a constructor is actually a special case of a function. It is actually a function, but it's a special case of a function. By a special case, it doesn't return anything, number one. Number two, it has the same name as so let me write it down. Um, Constructor does not return anything, right? And then case number two, constructor has the same name as the class. To my understanding, the reason why that is because you are creating a blueprint Um, uh, blueprint. I don't want all those other words. You're creating a blueprint to build that object. So hence, you're gonna give a constructor the same name as the thing you're building because that's what the constructor is building, right? Or is constructing. So it's constructing a person. So the constructor will be called person. And then there's different variations of constructors. If we think about it, there's different types of constructors. Basically, there's different types of builders, people building the object. You can have a constructor or a builder who needs a lot of information from the user. Basically, they're going to need to know what's the color of the house, what should be the color. Those are not the things that go into the blueprint. The blueprint only involves things like the size and everything, like the shape of the house, all those things. Does it have a double story or triple story or elevator or gym? All those things. Those are the things that should be mostly part of the blueprint. But then things like colors, right? That's like up to you, right? That's like a personal preference thing. So yeah, you can also pass in those details, those extra information. The extra information, just like a function, you pass in those parameters, right? Just like a function. Remember, a constructor is a special case of a function. So yeah, it does not return anything, not even void. It doesn't even return void. So that's why when you create your class, you're gonna model it in such a way that that constructor will not even return void. So now let's create a class. One thing you should understand about Java, right? Remember we talked about when you create a class, you need to make sure the name of the Java file it matches the name of that class. But in that class, you need to make sure it's also public. And you're only allowed to have one public class within one .java file. So therefore, the next class I'm going to create, I shouldn't make it public or else there's going to be a conflict, right? Java won't know which is which. So I'm going to just make it package private, right? So I'm just going to say class. Package private, it means that I don't specify any modifier here. So I just leave it empty. By default, it's what we call package private, meaning this thing is going to be accessible to classes that are within the same package as that class. If you remember packaging, that's what we're talking about when I say package. So let's say we're creating a class for a circle, right? Something simple. And then it stores a radius, so double radius. Um, yeah. So let me leave it like that. And another thing, another very, very important thing, very, very important. The difference between this variable declared inside of a class, you see that is declared inside of a class, and variables declared inside of functions. The variables declared inside of functions are not initialized. The variables declared inside of a class, they are initialized to their zero values. Meaning, if it's a double, it's just going to be set to 0.0. If it's a string, it's just going to be, is it null? Yeah, string has to be null. String is going to be null because they're reference types. So they point to something, to some reference, to some address. So by default, they're going to point to null, which is nothing. So that'll be its zero value. An integer will just be zero. A char will just be empty, right? Just like that. Or for C++, people, you can view it as like \0, which is just now. So that's the benefits. That's one of the benefits of declaring variables within a class. But remember, if you leave it as package private, it's like this with no modifier. By default, it's package private, which is not what we want. We want all of our variables to be private. That's why we're always going to append that private here. Unlike C++. Remember C++, the syntax is like this. You put private, then colon, then you do this. That's C++ syntax. C++. This is Java. Two different things. So I'm going to always declare it like this. Start with private, followed by the data type, followed by the name of the variable. Mind you, they get their zero values. Don't initialize them. So I'm going to leave it like that. And there's terminology, right? You need to understand terminology, the terms of OOP. When you're creating an object here, we call this instantiation, right? Basically, you're creating an instance, meaning you sort of like think of it as sort of like you're creating a version of this blueprint. So an instance, basically a manifestation of that, basically bringing that idea you're manifesting it into the physical reality. That's somewhat what that word instantiation is trying to explain. You're bringing that idea or that blueprint, which is this class over here, into physical existence, into existence, basically. We can say physical because it's inside the computer. So yeah, that's a whole deep topic on that. So we're not gonna go to that because yeah, now we're gonna start questioning if a computer's consciousness, things like that. We're not gonna go there. So instantiation, right? So this would be yeah, this one over here. This will be what we call an instance of that class. So this will be obj1 will basically be an instance of person. Basically, it's like it's one of the things that have been made based on that plan. That's why that's what we mean by instance. It's one of the things that have been created or constructed based on that plan, which is this plan called person class, right? That person blueprint. So if this is an instance, right, and you call anything, let's say you call a variable, right? So let's say dot name, you call a variable on that object, or you call a method on that object. Those variables and functions, they're called instance variables and instance functions, right? Because they belong to a specific instance, and which is true because you're calling it obj1 dot, meaning you want the one for this specific instance. Hence, they're called instance variables. As long as, how do you know if it's an instance variable? As long as it doesn't have static. That's the easiest way to know it. So this would mean this is an instance variable. In other words, right, it means that those variables, the only way you can call them is via an instance. Static variables, remember, they can be called via the name of the class, meaning they don't depend on a specific instance. They depend on the class itself. So hence they're called class variables. This theory, if I were you, I'll be writing down notes. They might ask you to distinguish between instance. Oh, hey, that's a very good question. What's the difference between an instance variable and the class variable? Ah, in the hour. I know some of you zero there, without a doubt. I can bet something there. There's quite a few gonna get zero on that question. I think I must email Mr. Ofao and give him ideas on how to set questions, especially for the not semester test 3, but exam. So let's create the constructors, right? So to create a constructor, it needs to be public, right? Because the thing that you're building, most of the time is going to be public. For example, let's think about it from a logical perspective. Imagine you make the car, right? Let's say that whatever car you make, that means it's going to be public, meaning it's going to be in a public area, right? Even if it's a private car, but it's in a public space, meaning if you park it there by Campus Square, it's in the public. People can see it. So obviously, the builders that are going to build this thing, we're going to use the keyword public for them because the things that they're going to build, they're most probably going to be public. You can, right, make it protected or private. You can, that's allowed. But we'll talk about that if we need to. Then I'm going to initialize it to some radius that I get from the user. You don't have to always have constructors. We just put them there. I don't know why, but yeah, most of the time you don't need constructors. You can actually work with only um, getters and setters, right? You can only work with those. That's still fine. And remember, we need Java doc, right? Radius, Java doc. Then we have this, and then we just set it to radius. So I'm going to say radius is equals to radius. This is what we call self-assignment, meaning you're assigning the radius to itself. If you remember scope, we talked about scope, right? You see these curly braces here. That means this radius that's declared here, it belongs to only the scope of the constructor. That means when this is how programming works. In any language, that's how it does it. Even in C++, any language, it does the exact same thing that I'm about to explain. It starts by looking for the radius within the scope first, within the curly braces. And it did find it, so it's gonna start on the left-hand side. Where's the radius? Oh, it's this one. It looks at the equal sign, oh, you're assigning. Then it looks at this radius. It tries to find it first here within the scope. It finds it again. Then it's like, that's suspicious. You're assigning it radius to itself. What spirituality are you trying to achieve here? So that's why it's most likely gonna show you a warning. It's not an error, but it's a warning. Meaning that, are you sure? Do you understand what you're about to do? That's why we use this keyword. So you say this dot, meaning this current instance, meaning I'm referring to this variable, to this instance variable. Go to this instance and then dot, get me the radius. Let me teach you something I'm going to teach you something that I think should be legal. So I'm going to teach you what's really going on behind, why do we need this keyword? This keyword, right? I'm going to make an example here. Let's say you have circle obj1. When Java meets this keyword, it's going to replace this keyword with obj1 like this. That's literally what this keyword is doing. And then if we had another circle, different one, obj2, when Java gets to where you're trying to call radius, whatever, it updates the reference of this to obj2. So you see that it accommodates all circles, all instances of this class. So therefore, we're gonna just use this keyword. That's what it means. If you didn't really understand I know you guys like cramming a lot. So if you really didn't understand, now you know. That's why if you notice something inside the Eclipse, do you see the colors have changed here? It knows this, you see this radius, it now matches with this color over here because it now knows the distinction. That means when it's gonna start here on the right hand side, right? There's no this keyword, so it's gonna start looking for it here. Then you're assigning, then it tries to put it back into this variable. It checks, oh, you said this, meaning that means outside of this scope. Then it goes outside of the scope, it looks like, oh, there it is over there. So that's why even Java, even Eclipse, right? We use different colors. So you see, this is a sort of like a darker blue, yeah, sort of like a darker blue. This is like sort of like a light blue. Then I can create what we call accessors and getters. So by making it private, right? Remember, it's private. That means the only person who has access to it is the circle class itself, which is actually kind of useless, right? If you think about it, it's useless, right? Not always, not necessarily always the case. It's not useless per se. So the private, it kind of limits the user, right, on the things, on the capabilities that they can do. That means we can make some features public and then some features we keep them private. For example, when you buy a washing machine, right, it's not, they don't create it with the see-through glass, right, so that you can see how the engine and everything is running. That's unnecessary details. The people don't care. They don't give a flying fuck of whatever how it's washing. They don't care. Can I put my washing? Is there start button? Is there wash button? Is there spin button? Is there dry button? All those, but that's the only thing I need to know. That's the power with private and this accessor modifiers. You can define things that should be visible and things that should not be visible. So it's not useless. It's very useful. So I'm gonna say circle and then just create a circle, right? Circle. Then I'm gonna say it's equals to new circle. And when you see when you use the new keyword, it invokes these different types of constructors because we are building the object, right? So you're gonna need to call the builder. And in Java, even in C++, when you introduce your own constructor. By default, you don't, to be honest, by default, you don't have to put a constructor. It has its own default constructor. You see, it still runs. It has its own, every class you create in Java has its own default constructor. But sometimes you might want to create your own specialized one. The moment you introduce your own, Java forgets that one that doesn't exist. The one that comes pre-installed. It is like it never existed. So that's why when you try to call a parameterized constructor, it looks for the parameterized one. Is it there? Nope, it's not there. Then it shouts at you. So that's why it's showing me that. So I'm gonna say my radius is 18.5 d, right? And then I pass my radius there. Then now I need to have a function that calculates the area, right? You can create accessors and getters, all those things. That's fine. So the thing is, if I create both, it defeats the whole purpose of making it private. But I can show you an example. So to make an access, right, because you want to access the value, you're going to use the keyword public or the modifier public space followed by the return type. Basically, what type of variable does it return? It returns a double. Space followed by the name of the function. Getters, since they get a value, they are prefixed with get. So that means you start by typing the keywords get in small letters, so get small letters, followed by the variable name that you're getting, it's radius, but you capitalize it. So get radius like this. And then it takes in all parameters because we're simply accessing. Then just simply return radius. Don't abuse this keyword, right? Remember within the scope here, is curly braces here. There's no other variable named radius. Basically, there's no parameter radius here, so I don't have to worry about Java getting confused. Which radius am I trying to refer to? So this would be how the accessor looks. In C++, right, you'd have your header file, and nah, Java, you do code it, you declare it and implement it same time, simultaneous. Unless if it's an abstract method. That's a different case. We'll get to that. There's a topic on that and interfaces. We'll get to that. Then now this is what is public, right? That means this object that I'm gonna refer to by the name circle in small letters. I can say dot to see the things that are available that I can access. You see, there's the get radius um accessor, right? And I'm sure you've noticed something, right? You see, when I scroll up, it shows me a lot of nodes, right? This nodes is Javadoc. My radius is no Javadoc, so it might showing nothing. I could just put here and say uh, get a radius. I'm gonna try and see. It should maybe somewhat show me something. Let's see. Okay, it doesn't. But this would be the Java doc. I guess you'd have to somehow import it. I don't know, generate it first. But this will, if after I've generated the Java doc, you could edit in your Eclipse to pick it up. That's a lot of unnecessary work. We don't have to do that. So you can also create a mutator, public modifier again. But then since it's a mutator, it shouldn't return anything. It should mutate. It should change. So just be void. So void, since it's a setter, it's going to be prefixed with the word set, followed by the thing you're trying to set. And then you capitalize the word for that thing you're trying to set. So I'm trying to set a radius. So set radius. Then you pass in the value that you're going to set it to. So I need to pass in another radius here. And you might ask yourself, why not just avoid naming them the same way? Just say R. What does the R mean? Does it mean reinstated, registered? Is it a value that represents whether you're registered or not? You see, it opens a lot of doors to imagination. I don't even know what R means. That's why even if it looks weird to repeat it, you repeat it because it actually represents a radius. I don't want my user to get confused. So I would actually be forced to use this keyword here because there's two variables with the same name here. Java might be confused which one I'm trying to refer it to. So this will be my mutator. They all look the same. Just depends on what you're setting. That's what's gonna usually become different, and the parameters. It could be having different parameters. Then you can have yeah, then I'm gonna yeah, this we pushed a lot today. Then I'm gonna create a function to calculate the area. So public double area. I wouldn't call it area. That's not a good name. Let's call it calculate area, right? That's better. Because remember we talked about functions, right, representing the functionality, or verbs, referring to verbs and things like that. So I can't just say area. Area is not a verb, it's a noun. So that's why I'm gonna say call it calculate area or calc area, but try to use the full name as long as it's not too long. Then it simply returns pi r squared, right? So pi is part of the math class, so you're gonna say math.pi, all right? R squared, meaning radius is squared. There's two ways you can do that. You can say times times radius, right? Mathematics, radius times radius. You simply add the exponents, which is just gonna be radius squared. So pi radius squared. Or you can type it manually. There's a power function in the math class. So anything that's related to math, you go to the math class. There should be everything you need there. So math.power for power, meaning you take a base and a power. The first parameter is the base, the second parameter is the power. So we're trying to say radius squared. So radius is our base. Squared is the exponent. And this function expects you to pass doubles, and it returns a double. So if for some weird reason you're calculating and you want to return an integer, don't forget to cast the result. All these functions, they return doubles, all of them. There's no function that works with integers. All work with doubles. Don't forget to cast to an integer, back to an integer if you're working with an integer. In this case, I want it to be a double. That's fine. So I'm going to pass in 2.0 d there. Yeah, this d is just to confuse those ones who don't read the textbook, and also the ones who don't attend class. That d, you should go figure out what it means. Yeah. Before I talk about something, right? There's something that I want to mention before we finish, but let me just simply calculate the area. So let me print the area, right? So I'm gonna say area is then plus equal string concatenation. Be very careful of string concatenation, right? Be very careful. If you say 4 plus this, right? Yeah, it's gonna work in a different way. Let me show you. If you say 4 plus 5, this won't output 45 space. No, it's gonna say 4 plus 5, that's 9. Then it appends the space. So you need to be very careful in what order you are putting your things. If you are doing string concatenation, always start with the string on the left hand side. Then the plus follows, and then you put numbers after the plus. Or you can call the .concat method. Go check your Java doc. And then I'm gonna say plus circle dot calculate area, right? So this will return the area and calculate it. You could put it in your own variable. I don't see the need for that. There's no need for that. So there's the area, right? But then this, you see that is kind of annoying in per se. Can't you see that it's kind of annoying having to always type this? Let me teach you a trick. Every single class you create, it has its own toString method. So meaning that it has a string representation of the object. So that function returns a string representation of the object. Hence it's called toString. And it returns that string representation of the object. So you can store it in a variable or simply just output it. So if you create any object, right, and you pass it via print line, print line actually caused, if it looks, it first checks if it's an object. If it is, basically if it's a reference type. If it is, then it's going to call the toString version or function of that object. And you can it calls it automatically. You don't have to append it. But then behind the scenes, just picture it in this way. It says, oh, dot toString, then it prints. But it calls it automatically. You don't have to put it there. Just know about that. You see that it's a weird output, right? So what I can do, right? I can do what I call method overriding. Remember this, every object, it implicitly inherits English. Implicitly simply just kind of means indirect. It implicitly inherits the toString method. So you can override it and provide your own specialized implementation of the toString. So when I say at override, to override, you put in the annotation code at override. At override, to be honest, is not really important. It's just what I call metadata. If you're doing informatics 2A, good for you. You understand metadata. For those who don't, go Google it. This just represents metadata. If I try to provide the definition, you would think it's stupid. So that's why it's best to go do your research. So public string, remember I told you to turn the string, and it's called toString. And then you've overwritten the method, and be very careful. Don't do this. This is all small letters. There's no method called toString with small letters. It's toString with the capital S. I don't know why most of these things I would have to really emphasize. You see, that's the problem when you don't read the textbook. Guys, go read the textbook because one mistake, your code is not gonna run no matter how much you pray. No assistant is gonna fix your code and say, okay, let's fix it for you. That's not how it works. You're on your own. If you don't study and you relax, you're busy there in your blankets, farting, you ate too much. That's on you. You're on your own when you write semester test two. So to give a string representation, I'm gonna make a simple string, right? I'm gonna say return area is then plus. Okay, let me be fancy. Let me use concat method. And then here, inside here, right? That's the thing. You need to know what you're doing. I know what I'm doing, so I don't have to worry about that. Inside here, you must pass in a string. And I'm trying to pass in calculate area, which is not a string. So you have to calculate area to a string. To do that, if you remember when we talked about the value of functions, you need to use that value of function from the string class. Yeah, it's unnecessary. I'm doing this on purpose to confuse those ones who don't attend. So yeah, all of this could have been avoided by just saying plus, right? So this could have been avoided by just simply saying plus this. I'm just trying to show off that I know Java, so I'm gonna do it this way. So that whoever tries cramming my code, you have a very hard time cramming it. So remember we talked about the print line method, it calls the toString implicitly, right? So this should output area is. So let me show you. See, there it is. Area is. Because I understand Java, because I read the textbook. Go read the textbook. So what if I want to round it off? There's a lot of ways. Like, to be honest, Java pisses me off the amount of ways that they're there to do something. So let me show you here. So I'm going to change this up a bit, right? I'm gonna use the format strings, right? So you could simply say string dot format. We talked about strings. We talked about this exact same thing. Then I'm just gonna say this is area is. Then here is the value that I want to be displayed in that section. I know it's going to be a double or float, so percentage %f, but I want to round it off to 2 decimal places. So I'm gonna say dot 2f. Then where there's null, I'm gonna call that function calculate area. Then this calculate area function is gonna return an area that will be placed in the specific section over here. But then that area is gonna be rounded off to two decimal places. Remember percentage F, that F stands for float, floating point. Then now at least the output is going to be a bit neat, you see? Round it off to two decimal places. You could, right? Like I said, there's a lot of ways. There's the round function inside the math class, so dot round to round it off. There's one that returns a long, there's one that returns an int. You must choose the right one. It's up to you, whatever approach um tickles your fancy. Whatever approach you wanna use, that's up to you. Java has many ways to solve something. That's why lecturers will can't understand why every student submits the code that looks exactly the same way. It's giving cramming vibes. So yeah, there's a lot of ways to do things in Java, and people have preferences. Not everyone is gonna have to implement the code the exact same way. So yeah, this is it for today. Now I'm tired. I'll zip the code and send it in the group. And okay, there's no notes, right? Yeah, do I have any notes here? Nah, you